All of you are able to see my screen. We shall start. Today on my agenda we have lambda functions. We shall see little deeper into lambda functions, and then we shall move on to pure virtual functions. In the last session we have seen what virtual functions are, and today we shall see uh, how to convert a regular virtual function into pure virtual function, and a consequence of that will be what are called as abstract classes. To begin with, we know lambda functions are short inline functions, right? And the way to define them are two ways. One is using the auto keyword, or another is using function keyword. So the way to define is auto name of the object. Then we have a capture list, right? So here we can take any variables which are there in the environment in which your lambda function is defined, and followed by we have argument list along with their data types, and there is an optional mention of what is the return type of a lambda function with an arrow in between. And then within the body of the function we have to define the lambda function. So after this opening bracket, you must close it here with a closing flower bracket and put a semicolon, right? Another way is to use function keyword. Here in the angle bracket we have to use specify the return type, and in the opening closing round brackets you have to specify the type of arguments the lambda function takes, and then the object name, then equal to capture list, everything else is same as above here. Okay, now these two ways of defining will be useful in different scenarios. If whenever you want to inject a lambda function into a method of a class, we have to use this notation. And if you want to define just a lambda function within your main or within any method of a function, then you can use this notation. So we shall see both the scenarios where this is useful and where this is useful. Okay.
Sir, just a question here, sir. The capture list in the auto thing, right?
Yeah.
So it should be always a fixed variable, right? I mean, we cannot modify the
Yeah.
variable and define as capture list.
No. We can modify. There are certain rules that apply. I'll show that. So, in what scenarios you can modify the capture list variables, and in what scenarios you cannot. Okay, so that part I'll cover quickly.
Okay.
Yeah. Now the next thing is initially you will have a lot of difficulties in understanding lambda function and implementing. So you know how to write a function, right? So let us see how I can convert this regular function which is adding two numbers into a lambda function. The way to do that is you start with the keyword auto here. I'm just converting this regular function into lambda function. Then remove this and from int from here. Then put a equal to here, right? So this after equal to put a square bracket for the capture list, and then your variables are anyway there, and then the return type which is optional, which you can put it here, and then within the body of this whatever is there, keep it as it is and put a semicolon. So just see how easy it is to convert a regular function into a lambda function. So if whenever you have difficulty in writing a lambda function, just recall how you would write a regular function and use it. Alright. So let's take an example which we have already done earlier, but let me clarify a few things about the capture list. Now if you have a lambda function withdraw, which is going to withdraw some amount from the balance that you have declared here. Now if I remove this ampersand here and use just the variable name, and then within the body of this, if I do a check balance minus amount greater than equal to 1000, I am going to allow the deduction. But if you don't put ampersand, you cannot modify the environment variable. Okay, so to enable you to modify the environment variable, you have to convert this variable into a reference variable by putting a ampersand here. Okay, so I hope I have clarified your doubt that
So we are not declaring that as a pointer, right? It's not a pointer.
yeah, this is not a pointer, this is a reference variable. I mentioned about reference variables. No, reference variable means this same variable is pointing to this variable now.
So basically the address address of the balance is what it points to.
Yeah, address of the balance where it points to, and then you can modify it. Now this is a single variable. Suppose you had one more variable here in text. Then if I want to use it inside, if you just say x here, then you can only use it, you cannot modify x. If you want to use modify x also, then put ampersand here. Okay. Now if you have too many variables, let's say there are 10 variables, for every 10 every variable you cannot declare here and say ampersand x, ampersand y, and so on. Just put just one ampersand. Everything that is outside can be modified within the body.
Okay, but we don't need to declare that as a pointer. This is a reference variable.
This is a reference variable.
Which is in C++. But in C we cannot do that, right?
Pardon?
In C can we do that, sir?
No. In C there is no such provision.
No, sir, right? Okay.
In C only pointers you can use. Okay. So if you put ampersand, it is called by reference. Okay. And if you want call by value for all variables, then just put equal to here. It's a funny notation. There is one equal to here, another equal to in square bracket. Okay. And if you put ampersand, it is called by reference. Okay.
Sure, sir. Yeah.
So equal to is called by value and ampersand is called by reference. So if you want specific variable to be called by reference, mention that name here. Okay. In this case, balance will be reference variable, x will be x anyway you cannot access, you have to mention it here, x, then x will be a call by value and balance will be call by reference. All combinations are possible. Okay, but if you want everything to be call by reference, put one ampersand. This much is clear?
Yes, sir.
Okay. Now don't forget to end the definition of a lambda function with a semicolon, because this is an object. So withdraw, what I am mentioning here is a name that is given to a anonymous function, because the function starts here. This function has no name. To refer to that, you have a object name which is withdraw. Okay, so this refers to some memory in the system where this lambda function is stored, and you can call that through the name withdraw. So in the following section, we can just call that lambda function here by passing some amount. So this amount what you pass here will go into this argument amount, and further computation take place. If balance is more than 1000 or equal to 1000, the transaction becomes successful, otherwise it fails. Okay, so this part hope you have clearly understood now. So let me show you in the code. Hello, good evening everyone. Welcome to my channel. Watch my video on Oops with C++ till the end. If you like my video, click on the like button and subscribe to my channel. Thank you so much. Same example so that you are comfortable using any lambda function. So auto name of the lambda function equal to square bracket. Then if you have declared a balance here, this is passing by reference. So let me define float balance equal to some, let us say 3000, and within the body of this, whatever argument that you want to pass, let us say float amount, and within this return type I need not specify, that is optional. Here you check if balance minus amount greater than equal to 1000, then you can say balance minus equal to amount. Just that you have to put a bracket here, and there is a spelling mistake here. And after this you can display also transaction successful, balance after deduction. You can show the new balance, and in the else part you can see out transaction. Okay, and before you start the transactions, balance before transaction, the regular statement, and here at the end of your function there should be a semicolon. Okay, so we know now how to define a lambda function, and if you want to call this lambda function, you just have to call it withdraw and pass some, let us say 1200. So is there anything to be checked? Run the program. Balance before transaction is 3000, transaction successful, balance after deduction is 1800 because I am subtracting 1200 from it, right? So is this example very clear to you? Hello?
Yes. Yes,
Okay,
sir.
okay. Now even if I remove this variable balance, it should still work because just ampersand means everything in the surrounding should be accessible within the body of this. Okay, so it does. Right. So when you have too many values to be passed to the lambda function, just put one ampersand. That should take care of call by reference. Okay, but few of them call by reference, few of them call by value, then you have to pass them separately. The rules that apply to the capture list I have listed here. So if you don't pass anything, nothing is passed. And if you pass just the variable without ampersand, it is called by value. With ampersand, it is called by reference. Okay, and just ampersand, everything is passed by reference. Sorry, I have made a mistake here. Called by reference, and if it is equal to, everything is called by. Now we know that lambda functions are used in testing. So let us see one example how I can use lambda function to perform a simple testing. We have seen how to build a function to add two numbers. So I am going to test that function which I wrote initially. So the way to do that is to define a lambda function by name test add. I'm not passing anything here, and it is accepting two arguments int a and b, and in testing we know what is the, we pass the expected value. Okay, so depending on the result of computation and the expected value, if they match, then we say test is passed, otherwise it is a fail. So here what I do is I take a local variable and call the function defined outside somewhere here. So I have to write a function here int add. So this function I'll be testing within my main. We'll see the demonstration of this also, but just before that we'll have to explain. So the result of computation which you get from the add function, which is here, is stored in result, and that result is to be compared with the expected value. If they match, test is passed for these values, and if they don't match, then you have a failed test. Once the lambda test function is ready, you can run the tests here. You can write any number of tests. So test add, this is for a successful test. 2 3 will add up to 5, and then minus 1 1 add up to 0, and 10 20 is a failure case. There is 10 20 will become 30 and you are expecting 25, so it is a failed. Okay, so let's see how I can use the lambda function to perform testing. So first thing is write a function add int x comma int y, and within the body of this you return x plus y. I can inject a test case into a method of a class. So before that, let us get acquainted with the syntax very clearly. Here I have to write a lambda function test add, something like that. This is the environment list which is empty. You are going to give an xy value here, and the third one is expected, and within the body of this you are going to take a local variable int result equal to, you are going to call the function add, where you are going to pass x and y, which will give you the actual computed value, and here you are going to check whether result is equal to expected. If that is the case, I am going to test case or test passed. Else you can write similar, and you should end the lambda function here. Now I have to carry out the test add 3 comma 5 8. So this should give me test case successful, test add minus 2 5 minus 2 5, result should be 3. This is also successful test add 4 5. If I give expected 11, then it is a failure case. So let's see whether all these things go through correctly. Okay, so test case passed with 3 plus 5 would 8. This test case failed, right? So just try this out. Would you like to try this out?
Yeah, sure, sir.
Okay.
Yes, sir.
So here we have to, in the failure case, you have to indicate what is the result you got and what is expected. So if I run the program, 4 plus 9 9, but expected is 11. Okay, so this is a failure. So as I mentioned to you, we can have lambda functions within classes also. So let's define a class account, and within this class, let's have two data members, customer name, and within this we can have the constructor parameterized one. So string customer name. So here I am going to write a method, and here I expect some amount to be passed by the calling function. Now within the body of this I can define a lambda function to perform that deduction. Let us say process. You can give any name, then square bracket. Within this we have to take amount as the argument which has come from here, and since I want to access everything from the environment, that is in the environment we have balance here. So if I want that to be accessed through reference, I just put ampersand, so that if I modify balance it will be reflected. So here what I do is I check again if balance minus amount less greater than equal to 1000. Now this lambda function can return some value, but if you are given a void here for both withdraw for this outer function, then it cannot send anything back. Suppose if I want to return something, I can put a string here, and here I can say return. So the method withdraw will accept some amount, and it will call this. You have to call the lambda function. The definition should get over here, and then you have to say process debit. Within this, whatever amount which has come, we have to pass here. So what we did in main, I am doing it in this method. Okay, so that's the only difference. But this has to be tested by creating an object in main and then calling this method withdraw amount. So our definition of class is ready and the method is also ready, and we are invoking the lambda function within the body of the method. Now here I have to create an object of account, and by passing some name here and some balance amount. Using this object name dot withdraw amount, here I am going to pass, let us say 1500, and this is going to return me some message which I have to, let's see what happens. See, the way we wrote the lambda function is exactly the same way we wrote it in main, just that we are writing it within the body of this method withdraw amount. Okay, and we are passing ampersand, that is because we want to modify the environment variable which is balance, which is the data member of the class. And as you can see, after transaction successful, you can also display the modified balance. It should show me whatever is the balance amount after withdrawal. 5000 was the initial balance, and you have withdrawn 1500, and balance amount is 3500. Okay, so this is another example where I am using a lambda function within the body of a method, and after creating the object of the class, I am invoking the method itself. Within the method, I am executing the lambda function. This part is clear now. Okay, so just try this out. Would you like to try this out?
Yes.
I think so. You should try, because this involves two.
So here, like we are need to change the balance, so we are just passing that ampersand in the lambda function.
Yeah,
right?
yeah.
What in case if we want to change the customer name also, like
Yeah. No, it is also accessible because ampersand
with
means
a single
everything.
lambda only.
Yeah, here if you want to change the customer name, no, you can say customer name equal to some Kiran. Okay,
Okay.
you can display that.
Okay.
Right. So if you write here, cout customer name changed to, so it was Ajay, now it is changed to Kiran.
Okay. With the single ampersand only we will
Yeah,
add
single
this.
ampersand will allow anything from the environment to be referred through reference.
Okay.
So this is one level of complexity we have seen, that is lambda functions defined within. Now let's take one more example where I want to pass the lambda function to the method. Sorry, we are defining a lambda function within the body of a method. What if I want to receive a lambda function into the method from main and use it here? So that is more useful scenario to consider. So let's see how we can do that. For that, we have to consider interesting example. Let us say we have a bank. Again, we have some balance in his account. Ideally, we should create a customer class and use it here, but I'm not doing it for simplicity. Now here I will have the constructor. Now, let us say the bank, when it wants to make when a customer wants to make a payment, we usually take help of a payment gateway. So let us say we have a method process payment, and within this I am going to call the payment gateway. Okay, so what is this gateway we shall see, and here the customer wants to pay some amount. Okay, now this gateway will be a lambda function, right? In a real scenario this will take you to the actual gateway, but I want to do the mocking. Sometime back you were mentioning about mock tests, so I am just exploring that part. Now here this has to be a lambda function. I cannot use auto here. Instead I can use the second definition, function. The return type of this, let us assume this to be a string. What type of output do we want? Okay, so in that case, this has to be string here. I want this lambda function to return a string and accept some amount here. Return type is string, then argument is float, and name of the lambda function is gateway. And within this, I am going to call this gateway the amount which I will receive here, and whatever is the return type of this gateway, I have to return back to the calling method. Everything appears very complicated here. Just hold on for some time. So this function is a defined object in a library function. I have to include that. So if whenever use a lambda function definition using function keyword, you must include a library function. Just note the name of the library function, it is functional. So if whenever you include that, this function, the error which was coming will vanish. Okay. Now what I have to do in main is I have to create the bank object B by passing customer name and some balance amount, let us say 5 crore. And here I have to define the lambda function. Let us say I want to use phone pay. So this is a payment gateway with ambience variable like this, and then it is going to accept some amount here, and this is going to return a string. You need not specify that. Now here what I am going to take as argument, I have to define this bank here and pass this object B with the reference, and I want to access the balance from the bank amount the way I did earlier. In the bank object, bank class, both of these are private. To make balance accessible, I should add a getter here. So I will make it float get balance, and only function of this is return balance. So what I do here is I do exactly the same thing what I did. This time I am going to use b dot get balance minus this amount. If it is greater than or equal to 1000, then I am going to return transaction successful, else return transaction paid. Let us keep it simple. Let us not display that balance and all. And this object is done now. So what I did here is I created an object of bank class and I wrote one gateway. Now this is a not an actual gateway. This is a mock gateway. It means it is behaving exactly the way an actual gateway would behave. It will accept the amount and it will tell you whether the transaction is successful or not based on some condition. I am putting a very simplistic condition here, just taking out the balance from the bank object and then subtracting the amount that has come here. Okay, so the next thing is I have to invoke the method of the bank object, that is process payment, and here I have to pass some amount, let's say 1200. Alright, and this process payment is going to send me this string transaction successful or failed, so I must see out it. And as the first argument to process payment, you must pass the gateway pay. So what I am doing now is I am passing the lambda function as the first argument to process payment. Okay, so that is why I declared the first argument in the method process payment as a lambda function definition. Just observe the lambda function definition here. Instead of using auto, I am using a function here and then specifying the return type using an angle bracket and then specifying the argument as a float. And this is where the first part of the lambda function definition ends, and you have to give some name to that object. I am giving it as gateway. This is some general gateway, and I am invoking this gateway which has come through the first argument by passing the amount which I have received as a second argument. So this function gateway will be executed here. It will check what is the balance amount of the object which I have created here, and if it is sufficient balance is there, it says transaction successful, otherwise it returns paid. So in this case it should return me transaction successful. Let us see whether that is happening. Okay, so transaction is successful. Okay, now the advantage is I have a PhonePe gateway here. I can have some other gateway like Paytm gateway. I can define and that will do a different checking. Okay, so here I can have Paytm whatever to call it as Paytm only. So the gateway can be different. Again, exactly the same definition you can take, but conditions you can apply differently. It means here when you define Paytm gateway, I will check for 2000 minimum balance. Possible? So Paytm may use different logic inside, but when you want to check with Paytm, all that I have to do is call this b.process payment, but this time you are going to pass Paytm here. Okay, and you pass 1500. What will happen now? You have withdrawn 1200 from 5000, that is 3800. Again, if you withdraw 1500, still there is enough balance. So hopefully, or will it lead to transaction failure? Let's check. Yeah, both are giving transaction successful, right? So that is now I am withdrawing 2500, 1200, 2700, right? 2000, 3200. The balance will go below 2000. Second transaction should be. That is the reason why it was not working, I guess.
Oh, the transaction.
Yeah,
Okay.
Otherwise, I should have just sent the set balance amount here, and there I should have done the same thing. Now let us.
Get balance amount we need to send it, and
It is below 2000 after subtraction. Let us see if one failed. Suppose if it is 1000 again, both should succeed this time.
now it's working, sir.
Yeah. Okay. So thank you for sorting out that issue. I was badly stuck, not knowing where.
I got confused, sir. So that's the reason I asked right.
Yeah, good observation. Because what happens in a hurry, things go wrong.
Yeah,
Now,
sure.
now as you can see, the testing is done properly. So like this, you can define any other payment gateway that you have, like Razor Pay, whatever. So you can write lambda functions to validate the debit cards or credit cards. That example we shall see in our next session. So before the payment is made, prior to this, one more test should happen. That I should inject a function which will test whether the credit or debit card is valid or not. So that will be a more interesting case. And only after the card is validated, you can call this gateway to perform the transaction. All of you are done?
Yes, sir.
Trying.
That argument is here, no float amount.
And then we add a function name.
Yeah, that name is here. This is the name.
So before that we give a function name, then followed by equals capture list and then the variable.
Just one. See, function, then angle bracket return type, then the type 1, type 2, whatever. Okay. Then object name equal to capture list.
So now capture list and R list what we are giving.
No, this is defining. Suppose if I want to only declare is only so much.
Okay.
Because this has to receive, no. So what I did in my this thing is function return type is a string, and here it is expecting a float object. Okay, I did float and then angle bracket complete. Then I said gateway. It means this declaration is now capable of receiving a lambda function which has this signature.
Just for declaration, this is the syntax.
Yeah, this is the syntax. If you want to define, then it should be equal to then all that.
Okay.
Got it?
Capture
No?
list by you, the argument and inside is returning the string. Okay.
This is clear, no?
Yes, sir.
Alright. Actually, I wanted to continue with pure virtual function and abstract classes. I think so that I should postpone it to next class, because I have to take one more example where we have a lambda function to validate the credit or debit card, and then go ahead with this process payment to make the payment. Okay, so that will be a more complete example to complete this session on lambda functions, right? So that we shall take up next week. To summarize, what we discussed today is how to define lambda function, how to convert a regular function into lambda function, and how to define lambda function at different places: inside main, outside main, inside a class, and inside a method in a class. Okay, and we used a method which will receive a lambda function. Okay, this is called as lambda injection. You are injecting a lambda function from outside the class into a method, and the method will behave differently based on what lambda function you have injected. Okay, and through this example we demonstrated how we can perform the testing using different lambda functions. Okay, so we have a mock gateway 1 and mock gateway 2, and you can see that process payment method is the same on the object, but how it behaves depends on what lambda function you are injecting here, and we got the result like this. Okay, so we shall stop here and we'll continue next session.